So I will try to give all of you a quick overview of the philosophy of IBISBA service modularization, and then Pau Ferrer will bring you a concrete example of what was done with multi-step access during TNA of IBISBA 1.0 project. So, sorry, yeah, okay. So IBISBA services, quite as other infrastructure at the moment, many partners that are members in IBISBA can provide one or many services. So at the moment, we've got a catalog of all the services provided by the infrastructure. And for each of one, you can have different types of thematics for the service. So for example, protein discovering and engineering, production strain development, bioprocess development and optimization, omics and analytics, TIA, LCA. So for example, you will be able to access to the catalog directly through the website and also within the links in this presentation. And for each of the service also, as Michael said, there is a link or an identification with the steps of the DBLT cycle. And also for each services, you've got quite information about the service description. So this is quite standard. So today and during the first step of the projects, service were accessible through single or multi-step projects. And what was done and worked during the first 1.0 project through transnational access was the interaction between the service provided by different members of IBISBA. And today, the philosophy is to think a service as a module. So we had a task force during IBISBA 1.0 was named Smart Task Force that provide a work for service modularization guidelines to transform a service into a module. And for that, we will need more information in the future on each service that will be provided through the catalog. So we've got some examples there. So service name, service description, inputs, outputs, start point description, endpoint description, facility metadata, and all input and output metadata also, because we have to better formalize inputs, you know, and outputs to ensure interoperability. We also won't catch and automatize everything, and we don't want to freeze internal operation in your facilities. The idea is to propose module as ready as possible for interoperability to accelerate internal partnership between members to guarantee customer requirements. So this will have an impact on the catalog and also on the new one-stop shop, because at the moment we have closed the one-stop shop on the website to work on that. And we will launch, for example, a form linked to that to get all the information about the services of our facilities. So in the future, we will bring also one-to-one services like the one that we have at the moment, and all-in-one services. We can think that soon we'll have, you know, the possibility to propose, once the customer will choose, for example, one services, to propose interactions that maybe he won't have thought, or maybe he didn't need at the beginning of his project, because or thanks to the modularization. So where are we now? So we are working on the new service catalog. And this is an example of service management diagram. For example, once you will be part of IBISBA as a new member, you will have to describe your service thanks to a service modularization form, the service will be validated. After, there will be a registration, sorry, to fix the service, like with the DOI or something like that. Then we will have a registration on the catalog with the website, and provide the accessibility to the service with the one-stop shop. It will be also possible to make a revision of the service or to remove it in the future if it's impossible for the partner to provide the service. So with the link, you will be able to have an overview of the help that will be brought with the service modularization form. So I will let you discover a few information with the link that I will bring to you in the discussion. And so, for example, we will have more information than just only the one needed. For example, with the facility information, like the facility contact, facility address, all the links for social media. Also, for facility services, maybe we will have a specific service manager if you have many services provided through the catalog. And it will be also possible to save and share the form with partners to give the most important and detailed information about the service. For example, with the typology and the format of the data to share from one service to another in the IBISBA catalog. So I think I have finished. I will let Pau now propose his presentation to have a true overview of what's in the real life.
Okay, I will try to give you some brief summary on how we executed the project and some of the learnings of this project in the context of service modularization and the needs we need to reach or we have for this to achieve this service modularization. So yeah, essentially the project outline it's depicted here. It's a company called Busy, a client, okay, came up with the idea of they have developed new promoters for recombinant protein production in yeast, okay, and they essentially wanted to test them at process scale and to see how feasible would be the implementation or the use at the industrial scale of these promoters. So our job in this project was to test them first at lab scale and then pilot up to pilot scale. Okay, so it's a project focused on the test step of the DBTA cycle. Okay, this is the very simple to design. We designed a very simple design, or we conceived a very simple design of experiments with some initial set of restraints provided by the company, producing some protein industrial enzyme. Okay, even for, let's say, the lab scale testing, we essentially designed a series of cultures, continuous fed batch cultures, with the aim to identify the optimal parameters, for instance, in terms of growth rate for production of recombinant protein with this new genetic tool. Okay, and we sort of decided on the experimental setup. Okay, and this in terms of workflow. Okay, we designed also let's say a simple workflow on how to split tasks, these tasks between the two partners involved in the project. Okay? So the important thing, very important thing here is to define with the company the input, okay, of this for the project. So in terms of which strains, how they grow, which conditions they need to be used in bioreactor scale cultivations, and also what are the constraints defined by the company. So that what sort of process the company wants to run at, or is thinking to run at the industrial scale. And for this, and taking all this information, we designed that all the series of experiments to be run at lab scale. So for instance, which number of cultivation, replicas, which operational mode, etc., etc. Okay, And this was the task done at UAB, okay? And the output of this, let's say, work, okay, or task was a series of data, experimental data from these cultivations. So essentially calculated growth parameters from chemostat and fed-batch data, okay, validated, okay, so we did data consistency, etc. And this data was used as a basis to select best operational conditions for scale up, okay. And then VTT did the second part of the project, which was testing at pilot scale, where they ran at 1.2 cubic meters the cultivations using all the information or the selected conditions at lab scale, okay. And they obviously we validated what we have selected at lab scale, okay. So critical issues in this project, the critical issues we identified for in first place, we had our first critical issue we find it's the design of experiments. This is critical. So the time frame of the project is and the resources are limited. So of course, a service of this type, R&D service, can be really diverse, and we can measure, run as many as experiments that we would think, but time and money is limited. So we had to define the minimal set of experiments relevant for let's say the desired outcome of the success of the project. Okay, and for this, strong communication between partners and also with the client was crucial. Okay, the other critical issues here that were identified, it's the harmonization of protocols, okay, or experimental procedures in the lab. Okay, how we analyze biomass, how we analyze product activity, how we compile data, raw data, and calculate process parameters. Of course, when we started the project, every partner was infrastructure was doing this in a different way, or even some protocols were from one partner and not implemented in the other installation. So there was, you don't see here that all the work that has done, but we done. But there was a lot of work of back and forth, okay, interaction between two partners to reach, okay, to agree on protocols, transfer protocols and know-how from one partner to the other, and then also agree on the data, on the data formats. Okay, so we had to transfer some raw data and process data to, for instance, VTT, all the way back, and we had to compare data from different across scales. So we needed common formats that at the beginning of the project we didn't have. Okay, so these are some of the examples of things that were issues that were identified during this test bed project that and we had to correct, okay, or modify, correct, or work on that along the process. Okay, so here I'm trying to summarize critical issues here. First one is communication. Okay, it's related to the interaction, communication with user and among operators. So for instance, this would involve even not only telcos, online meetings, but also on-site meetings or short visits from one operator to the other infrastructure. Okay, and essentially, yeah, all the protocols, all the work we had to do on the protocols. Okay, starting from very simple things on how you prepare inoculum. Okay, and as I said before, all the analytics that were required for the project. Okay, as an outcome of this work, we realized that some of the protocols needed to be curated. For instance, a protocol that it works in one installation, but in the other hands of another operation doesn't work. It means that there's some missing information in that protocol. So we had to curate some of the protocols, for instance, for product activity. And then we also identified missing protocols and gaps in terms of protocols and meta protocols. So for instance, we had a spreadsheet on how to calculate process parameters, but we didn't have a set of some guidelines to describing how you calculate these parameters. Okay, so the actual spreadsheet may be confidential, maybe belonging to each partner, but we need some guidelines. We realized that we needed some guidelines to common ground to agree on how we calculate such parameters. Okay, so as a result of this, so we did a lot of work also in the framework of this project of IBISBA 1.0 to write up de novo guidelines for, I don't know, how you run bioreactor cultivations. Of course, these are not specific to one type of bioreactor, so one brand of bioreactor, but should be agnostic. Okay, so but at least you should it's a sort of tick list of things you need, actions you need to take into account, which parameters you should monitor, etc., when you run a bioreactor scale fermentation. Okay, of course we had to go through all the analytics involved, and then we did also made new protocols on describing how to evaluate and validate and raw data, okay, data from cultivations, and also how to calculate process parameters, okay, in terms of, for instance, yields, productivities, etc. Okay, so this just to some quick view of things that issues that are included in, for instance, a meta protocol or guideline for running a fermentation. So, okay, it includes from how you prepare inoculum or the medium to how you sample, okay, volumes, etc., how you preserve samples, what do you monitor and control during the process, etc. Okay, and what is the standard output of raw data. For instance, we made new Excel sheets on to put all the data in a dedicated, in a specific format, units, etc., etc. Okay, and for chemostatic cultures, for instance, we did the same. Okay, so we wrote quite detailed guidelines on how to run experiments and how to present the output of these experiments, how to present this output data. Okay, so so I think I hope very briefly I was been able to do to show you the work that implies to really reach this point of modular service. Okay, where you can link different services. For instance, here we could think of maybe two modules. Okay, strain or process characterization at lab scale, and then scale up to pilot plant scale, and so how these two models, so defining the outputs and inputs of each model, and how to link them properly and in a smooth way. Okay, so there's a lot of tasks to be done in terms of standardization, harmonization of protocols, data formats, etc., etc. Okay, but at the end of the day, I think. Yeah, as Michael said, it's these projects are a nice test bed to really reach or reach to consensus best operating standards, okay, and knowledge sharing. So so this was a very good experience in this sense. Communication, it's essential, okay, and yeah, and you really need to go into the detail of protocols, methodologies that are used across all these services.